I'm Madam Hazika. I'm one of your maths lecturer at university. Okay, now we are going to learn chapter 12, applications of differentiation. For the topic of tangent and non-normal equation. At the end of this topic, you should know to find the equations of tangent and normal to a curve, including the parametric equation. If f prime x equal to dy dx is the gradient to the function of y equal to fx at point x1, y1 on the curve y equal to fx, the equation of tangent is equal to y minus y1 equal to m1 x minus x1, which is m1 is the gradient of the equation. m1 equal to dy dx is the gradient of the tangent to the curve at the point x1, y1. Okay, we can say also the slope of the tangent. Okay, say we have a curve y equal to fx, which is x1, y1, move around the curve. And then we have a tangent line, which is the formula just now, y minus y1 equal to m1 times x minus x1, which is m1 is equal to dy over dx, the gradient tangent. Okay, now we look at the example 1. Find the tangent equation to the curve y equal to 2x squared plus 3 at x equal to 2. Okay, we have an equation, and then we need to find the dy dx or the differentiation. 2x squared equal to 4x, and then we differentiate 3, it is a constant. Okay, we get 0. So the gradient for the tangent at x equal to 2 is dy over dx here equal to m1 4 times 2. This is the 4x. So 4 times 2 when x equal to 2 is equal to 8. And then we substitute into the formula. This is the y equal to 2x squared plus 3. Then we get 11. The point is 2 and 11. So we substitute to the formula. Y minus y1 equal to m1 x minus x. Okay, this is the value of y1, and then the value of x1 is 2. This is the value for gradient just now, 8. So we refresh this one, and we can get y equal to 8x minus 5. Okay, now we look at this size 1. Okay, we need to find the dy dx here, and then we substitute to get the dy dx value. Okay, we can get 8, and then the same thing, we get 11 just now, and then the point is 2 and 11. So the tangent equation is y equal to 8x minus 5. Find the tangent equation to the curve y equal to x squared plus 9 at 1 and 10. So that means we need to differentiate this one to find the slope, the gradient, and then we know that here the value of x is equal to 1. Then we substitute here, then we get 2. Since it is given the value of y here, so this one x1, y1. So it is y minus 10, y minus y1 equal to m1 x minus x1. So we solve this one, we refresh this, y equal to 2x minus 2x plus 8. Okay, look, here we have a tangent, and then we also have the normal line, which is it is a perpendicular. okay, perpendicular to the tangent, which is y minus y1 equal to m2 times x minus x1, which is m1 times m2 equal to -1. So this is gradient of the tangent times gradient of the normal, it is equal to -1. Find the tangent equation to the curve y equal to x squared plus 9. Just now we get y equal to x plus 8. Since m1 is equal to 2 here, we substitute into the equation m1 times m2 equal to -1. So we get m2 equal to -1 over 2. So from here, we can get the normal equation, which is y equal to -1 over 2x plus 21 over 2. Then we find the equation of normal to the curve given parametrically by x equal to 2 over t and y equal to 3t squared minus 1 at the point where t equal to 1. Okay, here we have x and t. So that means we need to get dx over dt. Dx over dt equal to -2 over t squared. Here we can use quotient rule, okay, which is v u prime minus u v prime over v squared. So here this is a u and this is v. So t times constant, we get 0 minus 2 times t power of 1 equal to 1. And then we get t squared. So that means we get -2 over t squared. Okay, so this is y equal to 3t squared minus 1. So we need to dy over dt with respect to t. Differentiation of y with respect to t. So we get 6t. This is a constant. We will get 0. So by using the chain rule, the formula is dy over dx equal to dy over dt times dt over dx. If you cancel out this one, you can get back the dy over dx. So since the formula is dt over dx, but here we have dx over dt. So why we change the value, we get dt over dx negative t squared over 2. Okay, from cx 60 negative t squared over 2 equal, we get -3 t cubed. When t equal to 1, how we get t equal to 1? Here, from information given. When t equal to 1, then we substitute, we will get the gradient for the tangent is -3. How to get the gradient of normal? m1 times m2 equal to -1. So here -3 times m12 equal to -1. So m2 equal to 1 over 3. So we have just now x equal to 2 over t. X 2 over t. So 2 over 1. 2 over 1 we get 2. And then we have 3t squared minus 1. 3t squared minus 1, so equal to 2. So x equal to 2 and y also equal to 2. So by substituting into the formula y minus y1, this is m2 times x minus x1. Okay. And then we can get the normal equation is 3y equal to x plus 4. Then given parametric equation, which is t cannot be 1, Find the tangent equation which is parallel to line 3y equal to x. Okay. The solution, dx over dt, here. Dx over dt, just now, you can get negative 3 over t plus 1 square by using the division quotient rule. And y equal to 2 over 1 minus plus t square. You can get dy over dt here. Then by using the chain rule, dy over dt and dt times dt over dx. This one is dx over dt. Okay. Kasih terbalik dia. Okay, we change the denominator and numerator. 1 plus t square over negative 3. And then we get, here we can cancel out. Okay. The negative also can be cancelled out. So you can get 4 over 3, 1 plus t. Just now, a line is parallel to the 3y plus equal to x. So if it is parallel, that means the gradient is equal. So from 3y equal to x, we can get the what we call as the value of m is 1 over 3. Okay, that means here y equal to 1 over 3 x. Okay, so dy over dx, just now we get 4 over 3 times 1 plus t. This is equal to 1 over 3. And then we solve this one, 4 equal to 1 plus t. So we get t equal to 3. Well, we substitute when t equal to 3 into the equation. Just now for x and y. Okay. Then we can get the tangent equation. This is the y minus y1 equal to m2 x minus x1. Okay, we can get to 24y equal to 8x minus 3. So you can do this exercise. And then the answer is given. Okay, we continue next slide for the next video. Okay, bye-bye.